Hey everyone, this is a video of me making a note card for the test tomorrow. So I've pulled information from the notes, from the practice test, and from different activities that we've done. So I'm going to include definitions and I'm going to include examples of the different things that we've covered throughout this chapter to hopefully help you make your note card. So here I've got it set up where I've got these two yellow rectangles. One is going to represent the front and the other is going to represent the back. Remember, you only get the one note card and you can write anything that you want, as much or as little as you want, on both the front and the back. So up here at the top, I've got a list of our major topics from the chapter. So we talked about integers and the meaning of zero. So I'm going to include some examples of those. Absolute value and opposites. So what absolute value means and how we evaluate it. And then all those things that we did with opposites and the opposite of the opposite and all of that. We talked about the quadrants and the axes. So what are the four quadrants? How do I know what kind of ordered pairs fall in those quadrants? And then how do I know if something is on the x or y axis? We talked about reflections. So how to reflect points across the x and y axis. So I'm going to do x and y axis here. And then we talked about distance, so how to find distance on the coordinate plane, and then how to find it in a real world context situation, like above and below sea level, that kind of thing. And then comparing and ordering, so I'm gonna try and put the checklist on here for comparing and ordering, and maybe a couple of examples of a little bit more difficult ones maybe that go along with that. So for integers, I'm going to say that integers are positive and negative whole numbers. So this is just the introduction of negative numbers. And then if I did a couple of examples, so I could do, for example, a withdrawal of $75 from the bank. A withdrawal of $75 would be me taking money out, so that's going to be represented by negative 75 or negative $75. And then zero is no change. Because if I don't take any money out of the bank, the account balance is not changing. Okay, so that's an example of no change. If I say something like, it is 35 degrees outside, the positive integer that I'm going to use to represent that is 35, and 0 means 0 degrees. And if I show a thermometer, so I'm going to draw a little number line over here. So here's my 0. Here's my 35 degrees. These are my temperatures above. These are my temperatures below 0. So 0 must be 0. It must be 0 degrees. If I say Tiger Woods is 3 strokes under par, under par is going to be -3. So again, if I use that number line idea, here's -3, that's under. This is going to be over, so 0 is going to be par. Another example would be if I used sea level. So if I'm above sea level or below sea level, so 0 means I'm at sea level. So this is just several examples of that 0 versus no change. These are more specific to 0 than the no change example. So that checks off zeros, integers in the meaning of 0. The next thing is absolute value and opposites. Absolute value is the distance from 0 on the number line. So if I have the absolute value of -5, that distance is going to come out as 5. If I have the absolute value of 13, it's going to come out as 13. Whatever goes in these bars comes out positives. And we've talked about that a lot, and I've had you guys say it a lot. When I'm looking at opposites, things like the opposite of -3, the opposite of -3 is +3. The opposite of the opposite of 8. This first opposite is going to be a negative. The second opposite is going to be a negative. The opposite of the opposite is going to make this remain a +8. And I could show many other examples of this as well. Excuse me. Just so you know how to interpret that word, the opposite. So that takes care of absolute value and opposites. Next thing is the quadrants and the axes. So I'm going to come back here. Here's 1, here's 2, here's 3, and here's 4. 1 is plus plus, 2 is minus plus, 3 is minus minus, and 4 is plus minus. The x-axis is the horizontal, the y-axis is the vertical. If I am on the x-axis, I am x, 0. If I am on the y-axis, I am 0, y. So that's a good way to quickly and space-savingly do the quadrants and the axes. So that's that. Next is reflections. So if I reflect across the x-axis, x stays the same. Y is the opposite. So if I have A is -3, 4, then A prime is going to be -3, -4. Okay, x stayed the same. Y is the opposite. If I'm reflecting over the y-axis, y stays the same. X is the opposite. So if I've got b is 2 comma negative 3, then b prime is going to be negative 2, negative 3. This time x is the opposite, and y stayed the same. That takes care of reflections across the x and y axis. For distance, remember if the numbers have the same sign, you're going to subtract. So same sign is subtract. If the numbers have different signs, you're going to add. So if I have A is 3 comma negative 4 and B is 3 comma negative 8, I'm going to look at these two and say, okay, these are the same. These are the ones that are different. Same sign means subtract. So I'm going to take the positives, 8 minus 4, and the distance is 4. If I have A is 2 comma negative 3 and B is negative 4 comma negative 3. The negative 3's are the same, so I'm using these ones. I have opposite signs, so I'm going to do 2 plus 4 is 6. Now we can have ones that are like the one from your practice test where we had the mountain up high and the grotto down low. We also did examples with birds and fish. So if I have some water and I've got a bird up here that's 50 feet above sea level, and I've got a fish that's swimming, let's say negative 20 feet below sea level. To find their total distance, I'm going to do 50 plus 20 and get 70 feet. So that's another little mini example of finding distance. The last thing that we had was section 4.4, which was all the comparing. So I've got my comparing checklist. So if I got my comparing checklist, number 1 was positive versus negative. Number 2 was proper versus improper. Number 3 was different whole numbers. Number 4 was same numerator. Number 5 was compare to 1/2. And number 6 was common denominator. So this is just like what the checklist is. You can include examples of how to use the checklist, but for a lot of us, just having the checklist and being able to see it is going to be helpful for us. So this is the note card that I have put together. I obviously wrote pretty largely while I was going through this. The front side is not near as full as it could be. So you can move some things around. You can include more examples. You can include more pictures. I didn't include many graphs for reflections or distance, but you can. Excuse me. And again, I covered every item that was on my checklist up here. You can always add more things if you are able to fit more things. You can include less things if you don't need as much. Many of us might need a lot more of these examples, so feel free to include more from our notes. And then please let me know if there's anything else that you think you need to add or that maybe I missed. And I can include that in future ones. So good luck making your note card, and I hope this video was helpful.